All right, hello. We are going to talk today about the third and final rigid motion, which are rotations. Okay, so a rotation is a rigid motion, yes, and we can kind of see how that is acting out here in this picture. To write it in words, we would say this would be rotating the pre-image UVW, a certain number of degrees about a center, which is Q. So we can kind of imagine the red is some sort of like maybe fishing line that's tying V and Q together, and we're almost swinging it an angle X in this direction. Now this is counterclockwise, and this is considered positive. So when I say rotate 90 degrees, I'm talking about rotating counterclockwise. So again, this would be clockwise, and this here would be counterclockwise. All right? So how does it work? Let's take a look at just doing this for a point, which is kind of all we'll do. We're going to take this point and rotate it around the origin. So again, we can draw that dotted line, and we imagine that this is going to swing over here, maybe somewhere and land here, and that is 90 degrees, right? Okay. But now how do we know that the point is there and not here, or here, or here? We really have to use some sort of guideline or some sort of helper shape to really rotate this. So what I'm going to do is I'm going to take this T shape, and let's see if I can get a better grip on it. Okay, and I'm going to rotate it 90 degrees like this. Okay, so we see that our point was a little off, right? It really should be up here. And it is going to go up 5 and over 2. So we can see that F, which was 5, 2, was rotated to -2, 5. If we do it very carefully. So we're going to use that L shape a lot here in the notes. So like I said, unless otherwise stated, rotations are going to be performed counterclockwise. Okay? Let's practice this now. So let's go ahead and plot E and F. And we are looking, see what the notation says here, to rotate this 90 degrees around the origin. So I'm going to draw my L shape coming from the origin up to E. And then I'm going to rotate this 90 degrees, trying to keep all the lengths the same. So this would be how we place E prime. Okay, so down here, I would say E 1, 4 goes to E prime, which looks like it's at -4, 1. Okay, and F will do the same thing. So I will erase my guideline and draw a new one for F. Okay, and I will just try and rotate this. I'm keeping my one finger fixed at 0, and the other finger I am rotating through. Trying my best. We see it goes out like a length of 5, so I know it has to be that big. So F is up here. f prime. So that is at -2, 5. Okay. So what's the coordinate rule then? Well, a generic point x, y is, it looks like the 1 and the 4 swapped places, and the negative sign was placed at the beginning. So this is the rule for a 90-degree rotation about the origin. Alrighty? Okay. Let's do this again. So -2, -1, -6, -3. It's B, this is A. And this time we want to rotate it 180 degrees about the origin, which is just two 360-degree, two 90-degree rotations. Okay, so we can kind of just perform the same exact thing and just go one rotation farther. So with A, I'm going to draw my L shape, and I'm going to go ahead and rotate him once, and rotate twice. How about that? So that is going to be A prime. Okay, so we'll use a different T shape. So you might do this lightly with pencil. I have an advantage for using technology. So we see that my L goes all the way to -6. So when I rotate this once, I want to make sure that I'm trying really hard here. Come on. All right. It really doesn't like that. All right. So there we go. Okay. So it goes out to -6 right here. So I want to make sure when I rotate this over here, it's still like 6 long. So that looks a little bit too big, like that. You see? And then I want to rotate this one more time, making sure that it does stay the same length. There. So that's where B prime is. Okay. Let's go ahead down here and update where our points went. So A prime went to 2, 1. B prime is at 6, 3. So what is the coordinate rule here for a 180-degree rotation around the origin? Well, the 2 and the 1, they stay in the same spot, but they lose their negative sign. It just goes away. So we're going to take the negative of x and the negative of y. And that's going to be our 180-degree rotation. Okay? So again, just kind of observing our images and our pre-images. Finally, we're going to do a 270-degree rotation, which is 3/4 away, 3/4 the way around the circle, right? So let's label, and we're just going to use that T thing again. So I don't want to bore you too much, so I will just kind of show you here. When we rotate this once, it's going to go down here, right? Rotate it again, it's going to go down there, and rotate it once more, and it's going to go out there. What I'm doing when I'm doing this, I'm making sure that my L goes out to 3, whether it be 3 or -3. I know that it has to be 3 long, and by doing that, I'm kind of ensuring that I don't get too messed up. Okay. D is going to be the same way. So I'm going to actually draw all the L's for you, and I'll go ahead and just do it as a rainbow order. So there's the first L. And when I bring it up, I need to go up 5 and over 2. And when I start with green and go, I'm going to go 5 and 2 still. And finally, I'm going to go 5 and 2. So you can kind of keep that, if that helps you, to go, oh wait, hold on. I messed up, didn't I? It's 5 and 2, but it goes up this way. And the blue goes down here and over here, right? So anyhow, that is how this is going to rotate. And this is going to be a D prime. So this one's kind of a lot, and it's really easy to get like messed up on this. So, but you do see these are actually perpendicular, which is a kind of an after effect of this. Yeah, so where are C prime and D prime? Well, let's first see where we start. Looks like C prime is at 3, 1. And D was at 5, minus 2. And D prime is at -2, -5. So talking about the coordinate rule, like how do the number, what's the pattern? We see that the 1 and the 3 here, they flip, and then a negative sign shows up at the beginning. So we flip the 2 spots and put a negative sign at the beginning. So this would be a 270 degree about the origin. Okay? So what happens if we don't rotate around the origin and we don't start those L shapes at the origin? Well, I'll show you. So this one has the origin is no longer there. It wants us to rotate around this point here, which is 3, 2. So now when we rotate, we're not going to be connecting our L shapes to the origin. We're going to be going from the rotation point over and down. And then when I rotate this 90 degrees, it's going to go here, right? So it should rotate here. And that should be our new point, because it is a 90-degree rotation still, right? And you do the same thing with G. So that's my L shape, and when I bring that down, move this one, it does something like that. Right? So the picture's a lot kind of messy here, but that is our image. Okay? So what are the endpoints? Well, G goes, well, let's just list them. There's no coordinate rule, or you could make a coordinate rule for this stuff, but we're not going to. So G prime looks like it's at 2, minus 1, and H prime is at 4, 0. I'm just going to leave it at that. Okay? Great. So part 1 of the video is done. Now we just need to talk a little bit about the rest of the notes here. So M is the center of the square, and we need to find the image of each rotation. So this one you want to rotate A 90 degrees about M. That's what that notation means. Lowercase r we're going to use for rotate. So yeah, if the A goes 90 degrees, it's going to pop down here. You can imagine just taking this square and rotating it 90 degrees. A is going to go to D, right? And what if we went ahead and took BC as a line segment and rotated it clockwise around M? So that would be like, this is M, so it would be like doing something like this. That would be clockwise, right? So it looks like in BC, it became CD. In that order, the order matters, because if you watch what happens to like the line segment, where it was at B, there. So that top part, when we rotate it down, that is mapped to C. So we got to make sure that like the B and the C like match up. They're both first. Okay. And same thing, if we're at DC and we rotate it 270 degrees, that's going to look something like, trying to do it for you, 90 degrees, 180 degrees, and 270 degrees, like that. So you have to visually kind of see that. Again, this is going to go to, it's actually CB. Oh wait, hold on. I think I went the wrong way, didn't I? Sorry about that. I went clockwise, didn't I? So easy trap to fall into. So we want to take this and go this way. This is the positive way. So that would be 90 degrees. That would be 120, 180, and this would be 270. So this does go to AD. Okay. Again, making sure that D goes to A and C goes to D, making sure that like those letters match up there. The order does matter. Okay. Let's talk briefly about this. If you want to estimate the angle of rotation, you should pick a point on both. Like I'm gonna pick the top of the F in the corner, and then all you gotta do is match this up with your center and draw an angle, and that is the angle that we're gonna turn this black F. Okay, to me that looks, I don't know, about 105 degrees, and it is going counterclockwise. So it is positive. With the blue one, it's less is up to chance, right? We're gonna take this figure. Let's see if I can do it for you. And we're gonna visualize spinning it around like that. Oh, that's pretty good. So you just gotta think, okay, well, how far did you spin? So we were here, and we did 90 degrees, 180 degrees, like that. So this one's more exact, but you could still kind of play that same game of like trying to match up a point like this one to like where it ends up, which is kind of a 180 degree turn. But anyhow, so yeah. I wanted to talk also about quadrants. So we've been doing this L-shaped thing, but there are other ways to do rotations mentally. But it starts with knowing the quadrants. So quadrant 1 is plus plus. Quadrant 2 is minus plus. Quadrant 3 is minus minus. And quadrant 4 is plus minus. So when they have M at 3, -4, and they want to rotate it 180 degrees about the origin, we can just estimate what quadrant that's in, because if it's 180, then it's going to go to this quadrant, and then it's going to go to this quadrant. So this should be 2 quadrants away, which would be quadrant 2, right? And if we did map this out, I can tell you that it's going to go here at -3, 4. Yep. So there is kind of an interesting way. I want to scroll down to the bottom to kind of have more space for this. But if you're interested in another way, oops. If you have a point, so if you're going to do a 90-degree rotation, 180-degree rotation, 270-degree rotation, or let's just leave it at that. And if you have a point, like so basically a 90-degree rotation is going to increase, rotate through one quadrant, and a 180 is going to rotate through two quadrants, and 270 is going to rotate through three quadrants. So when you have a point like 2, 3, if I ask you, hey, do a 180-degree rotation, you're going to know that it's going to rotate through two quadrants, 1, 2, and it's going to land somewhere in here. We know by the coordinate rules that we wrote at the top in the three boxes here. We know, here, let me show you. We know, and I want to keep this brief too. I don't want to go on too much of a tangent, but we know these coordinate rules, and this is a helpful way to remember them. Yep, those were, yes. This is basically telling you that if you have a point X, Y, and you want to do either a 90 or a 270-degree rotation, you're going to have to flip the two numbers. And if you do a 180-degree rotation, you don't flip them. You see how they both have X, X, Y, Y? So one way to do it is just remember that a 90 and a 270, you have to flip them. But with all the rest of it, like the negative signs, you can just see what quadrant you're in. Like, again, for example, here, we know that a 180-degree rotation is going to land me here, and that's a negative negative. So I then know that a 180-degree rotation is going to land me here, and I know that I don't flip the X and Y, and I know that third quadrant is negative negative, so that has to be the point. Okay, so we talked about this a little in class, of like just predicting it based on what quadrant you're in. So maybe I can talk about point T a little bit in that light. So remember, you can always use that L shape if you want. But so if they have T and they want to rotate it 270 degrees, I know that's going to land me 90, 180, 270. That's going to land me in quadrant 2. Okay, and I know that 270 degrees is a flip. So what I'm going to do is just write 4 and 2. And I'm in second quadrant, so it should be minus plus. So that is the location of T prime, which is right here. So this is in quadrant 2 as well. So just remember that 90 and 270, they flip the X and Y, they change places, but with the 180-degree turn, they stay the same. And then as long as you know what quadrant you're in, you should be able to get the negative signs right. Okay. Last thing, just kind of like as an extra throwing it out there for standardized tests maybe. Triangles have lines of symmetry. They have 3 of them. You could fold across any of those lines, and the triangle will line up with itself. Okay. The triangle also has what's called order 3 symmetry, rotational symmetry. Rotational symmetry is like the number of times you rotate the triangle and it lands on itself in 360 degrees. So if we had that triangle and we rotated it 120 degrees, so if we want to see this, so, oh boy. So if we had this and we rotate it, that would be 120 degrees, we land there. And then 240 degrees we land there, and 360 we land there. Versus this rectangle, it only has order 2 rotation because it only lands on itself twice when you rotate 360 degrees, which is at 180 degrees and 360 degrees. So again, imagine rotating this rectangle. 90 degrees would be here, 180 would be back, and then 270 would be back here, and then 360 would be returning originally again. I won't test you on rotational symmetry, but that's how we describe it. Lines of symmetry of the rectangle, you could fold it in half like this or like this. So there are 2 lines. Okay. I know that the end of this was maybe a little disorderly, and I just kind of threw some stuff at you. But the key focus here is understanding how to rotate in the plane, and using this L shape is one way to do that. Okay. So focus on that if you would.